Hello world. Today we're going to go ahead and, have you ever had a long day and things just aren't coming out right? That's today. So we're going to use the Polygon API to grab minute data. And we're going to take that minute data and put it in our database that we created in this series here, right? The goal of my channel essentially is to track the markets, figure out what really works through the lens of data science and back testing, right? Why? I don't know. I'm weird. I just love this stuff. Okay. So that's the goal for today. But we can't just use the Polygon API itself. It isn't sufficient for our needs exactly, right? It allows us to grab data, but we need to add the ability for it to have what's called a retry strategy or reconnect if it has problems. And we also want to make sure that we can grab all of the historical data, by having a start date and an end date. Polygon doesn't allow you to do that. My guess is they're trying to limit massive API calls, but we're going to take that API that they have and improve upon it. So that's what we're doing today. I hope you're excited about it. So let's create some code. So the first thing that we're going to want to do is we're going to want to open up our Jupyter notebook. I've got a few basic titles here. But we really want to install the Python Polygon API client into our virtual environment. Now, if you don't know what virtual environments are or haven't used virtual environments before, I'll put a link in the description below because you definitely don't want to be installing a bunch of software into your global environment. So first things first, go ahead and run bang pip install Python API client right within the Jupyter notebook. Get that installed. I already have that API installed, so no need for me to do that there. So the next two lines of code, so now that we've imported or installed the Polygon API client, we can import the REST client from the Polygon API. So we're going to do just that. And then the next line of code, local settings, just contains the API key for Polygon. So we did something very similar whenever we were connecting to Postgres using SQAlchemy. You can see that this file, local settings, is just contains dictionaries of the various key value pairs of what's needed to create those connections to be able to connect to SQAlchemy. So essentially, I have one right now that you don't see, but I'll upload it after this lesson. This Polygon equals API key, colon, then the API and key value pair, right? So that's that. So I'm going to hit enter here. Now let's create a Polygon client from the REST client. Client equals REST client. What do we need here? Init, looks like we need an auth key that's a string. Don't need to worry about the timeout. So let's just go ahead and add a string there as the API key. So settings API key. Okay, and then client, that should give us a REST API client. And it does. We can see here's the REST API client at that memory address. Now we will see what's available to us using this client. If I type client, period, and then hit tab, it shows us all of the various methods. Why don't we use the stock aggregates? So we see stock equities aggregates. I don't know exactly right off the top of my head what's needed. Go ahead and read the documentation found on Polygon.io. Like we need the ticker, multiplier, time span from to. Okay. So the ticker is we'll just use Apple, that's fine. Multiplier, essentially we were saying minute, we could 5-minute bars instead of 1-minute bars. We'll just keep it at 1 minute. Time span gives us various different time spans. So we'll just keep defaults here and we'll just get the 2021. We'll get the January 21 data. All right, so ticker, the Apple, multiplier, 1, time span equal minute, from equals 2021-01-01, and 2 equals 2021-02-01. Everyone to okay. And we want to obviously return this in a response. And then that should give us a response, right? So we're using the Polygon API client. We're making a request, which is essentially wrapped in Polygon's API. So we're not worrying about the actual uh, URLs and things like that. It just all of these methods for us. We return a response which has various methods such as results in it. So let's go ahead and hit enter, see if that worked. It does look like it worked. So let's see what is available to us. Response period and then tab. I see various items here. What I want to see are the results. Okay, I believe that's in a dictionary format. Okay, great. So this is the open, high, low, close. Let's see. I guess that's VWAP, volume, VWAP, open, close, high, low, transactions, and no time. And oh, I don't know what N is. That's okay. All right. So now what we want to do is we want to get this data into a data frame. Pretty easy to do. So we'll do import pandas as PD, and then df equal pd data frame to response dot results, and we'll print out that data frame. Maybe that's probably number of transactions, time, volume, VWAP, open, close, high, low. So that's what that is. Okay. So now we have our data frame, 5,000 rows. Perfect. Let's see here. This isn't very useful for me because I don't exactly know the amount of time that passed by. So we'll do this. df date equals np2 date time. We'll put it in f and unit equal millisecond, and that should give us the actual time. Oh, ed. All right. The point what I'm trying to show you is we only got data to the 11th. Okay, so that's part of the challenge with this. Okay, so let's go back and look at our response object, and does it provide like a next URL or anything like that? And it doesn't. So that's part of the challenge with this API, is that it doesn't provide what your next query should be. So you have to handle that. So if we want to grab a month, we could probably get a month by going through and changing the limit to 50,000. The default was 5,000, which is why we got the 5,000 rows. But once we start wanting more and more data, we're going to be limited to that 50,000, and we don't have the next URL, or it doesn't help us in that regard. So that's what we have to fix. And the second thing is, we don't. If we're going to be downloading hundreds or thousands of tickers at minute resolution, it's likely that there'll be disconnects and retries and things like that. So we also want to add that too. So, so the great news is we've used the current Polygon API. We've got the data, but we need to modify that API in order to make it both sort of a little more resilient, and also to be able to automatically grab that historical data, as opposed to us, just kind of guessing what the next 5,000 rows would be, if that makes sense. Okay. All right. Perfect. So let's create a new title and go from there. Before we dig into the code, let's think about what we need to do. So we need to create a retry strategy, so that way if for some reason there's a disconnect or we get some type of error, we can look at the HTTP code and determine, what, are we going to retry this specific command that we just attempted? And, what is the delay on that going to be? That's the first thing that we need to do. The other thing that we need to do is we want to create our own methods for getting the tickers and getting the bars. So I wanted to take a step back and kind of, before we just dive right into code, get a real good conceptual understanding of what we're trying to do. Okay, let's get back to the code. And we call this improved Polygon API. Okay, and let's add our steps. We'll do add retry strategy. And we'll also add get tickers. And we'll also get get bars. That'll be essentially what we're doing. Okay, so the first things first, let's add our retry strategy. So we can go to the original REST client, right? And you can see all of this code here. We don't have to override any of this stuff. We're just going to use it. We just have to add our retry strategy in the init. So I'm going to copy this, okay, and paste it here. Right, so now we have our REST class, but we're going to call this the my REST class. We'll inherit REST class. Okay, makes sense so far, right? And then add in, right? Because the default API, or see if I go back here, right? The default host, that's part of this REST class, right? So whenever we do a super and init, we will get all of that. So we'll do super init auth key. So what are we doing here? Basically what we're doing is we're saying, okay, let's go to the super class, which is the REST client, and run its init method, right? And passing in the auth key, okay? That gives us access to everything that we need specifically to use the session, but you'll see that in a minute. So we'll do retry called super, retry strategy equals retry total. I'm going to have to actually import this, but we'll do total 10 times, back off factor equals 10, and then the status force list equals, then we put in a bunch of HTTP codes, so 429, 500, 502, 503, 504. Now, if you're wondering where to get this, just Google retry strategy for requests. Okay. So speaking of requests, we need to import that from requests adapters, import HTTP adapter, and from URL lib free util retry import retry. Okay, so that's what we need, right? So we've got our HTTP adapter and our retry strategy. Okay, so now what we can do is, remember, we already have all this stuff. When we called super, it gave us all of this stuff. The only thing that we really want to override is this, because we want to mount, and we want to use this session, but we want to mount our adapter. So see what I mean here. I can delete all this, right? Because that's already taken care of in our parent class. Okay. Then I'll do adapter equals HTTP adapter max retries equal retry strategy, which we just defined above, and then self dot underscore session dot mount HTTPS colon front slash, and that's the adapter that we just created, right? So basically, again, to recap, we're creating our own MyREST class. We're inheriting all of the REST client functionality. We're able to use this underscore session session.mount because we use super here. Then when we call super, we get all of this stuff, right? Make sense? And then again, that's pretty common. So awesome. You should have a good understanding of that. Now what we'll do is we'll try to create a client for our REST client, right? So we'll do client equal my REST client, type of 4, and we'll do settings, pass in the API key, and assuming we did everything correctly, which looks like I didn't, my REST client, oh, that would be why. And okay, and it looks like we have it there. Now, what's cool is we can hit period, hit tab, and look, we've got everything that we had previously on the original, original Polygon API. So we have all of that functionality there. The only thing that we changed was we added this HTTP adapter with a retry strategy. Okay, awesome. Okay, so now the next thing that we need to do is to get the tickers. Okay, so we'll add a space here, and then let's see what that reference tickers v3 actually does. See where we're at. We'll go tickers, ticker types. Is that reference tickers? So what are the parameters? Okay, stocks, options. So basically we have to pass in a market and potentially a locale. So let's try give this a shot. So we'll do client dot ref tickers v3 and then market equal crypto. And say this response, if that worked. We did get a response, period tab to give us our options. You can see here, this is what I was complaining about before. Whenever we were getting the data, there was no next URL. Let's see if there is a next URL here. Depends on, yep. So it does seem like we can get the next URL, which will get the next part of our, ticker list. Okay, and then results. So that gives us, so all of those results. And we can easily put that in a data frame if we want. Let's do that now. Okay, so get a new column or row, import pandas as PD, and we will simply do pd.dataframe, resp response, if equals, and see if that worked here. Oops, results. Okay, perfect. So, and then obviously we can slice and dice that however we want. But I think at this point, we have everything that we need to create our ticker method, right? And let's see, remember, it's a method because it's part of the class. We're actually going to copy all of this, paste this here. And now what we'll do is we'll create that get tickers method. So we'll do def get tickers self, and then market. We want to pass in the market. It'll be a string. Again, I'm just putting type ins here. It makes it easier for people to kind of understand, right? So if you're not familiar with type hints, essentially, just shows you market. We expect a string. Right now it's none, and this will return a data frame. Also, here. Let's create one of our markets. We'll do markets equal crypto. We'll just do stocks for right now. See what I'm doing in a second. We'll say if not market in markets, phrase exception, right? And we should have market. So market must be one of markets. Okay. And now what we'll do is we'll use that reference tickers method, which we currently have access to because we have a subclass to get those bars. So we'll do response self.reference tickers v3 market equal market. Okay, and then what we'll do here is we'll say if has attribute response results, right? Because what happens if we get a response that doesn't have any results? I want to make sure that that exists. If it does have results, data frame equals PD data frame response results, just like we just did previously, and then while has attribute response next URL. We saw that, right? While there's a next URL that exists, we want to make a new request and get a new response. We'll do self reference tickers v3 next URL equals response next URL, right? As we saw that previously, whenever we saw that the tickers had that next URL, once we get to the end of the list, it won't have that anymore, right? That'll be the last response. And then we'll just append these on top of each other. So df equals df.append dd data frame response results. Okay. And then the if, that'll be all of our results. And then if market equals crypto, let's do only use USD pairings, right? And we'll do df equals df. We'll do some Boolean logic here. Currency symbol equals USD. So I only want anything where the currency symbol has USD, which just means it's a US dollar pairing. And then the name right now, we'll just set that to the base currency name. So base currency name. Remember, we did this up here. So the base currency name is, 1 inch or essentially oh no, it's right here. That's a base currency symbol. Base currency name right here. So alpha cat or a cat, right? Okay. I just want to show you where I'm getting that if you get. And then I only want certain fields. Remember our entity relationship diagram or ERD, we're only concerned with ticker, name, market, and active. Okay, and then this is almost everything that we need to do. So we'll just, for good measure, df.drop duplicates. It does happen. Duplicates, subset. So if the ticker is duplicated, we want to drop it. It'll just drop, I believe it's the second one. It's the exact match. Then return df or return none. So the return none, it doesn't actually have to, I like to make it explicit so we understand how we're handling that. But essentially, we get tickers if there aren't any, it will return none. And this could be, optional because it returns none too, but that's beside the point. So for our intents and purposes right now, this looks good. So I'll hit enter. And let's see how many typos I made. The client equals my REST client settings. Again, just passing the API key in, which then gets passed into the init, which then gets called with super, right? That's where all the magic happens. And then df equals client.get tickers and market equal crypto. Yeah. Okay, see, I knew there would be something here. Drop duplicate subset. And that's it. Perfect. So now let's just kind of recap. We ended up, overriding or adding retry capability, a retry strategy to our REST class. And we created this get tickers, which will loop through all of the next for us automatically, right? Append it to a data frame and then clean up the data frame if it's a crypto data frame and return it. And that's what we see here. Perfect. So that's the easy part. Now on to a little bit more challenging, which is the get bars. And because again, it is a class, I'm going to copy all of this, paste it down here, and now we can start working on our get bars method. Get bars. So now we'll do type market. It'll be a string, ticker, string, multiplier, int 1, time span, string equal minute, and then from date done, and to date done. That will return a PD data frame. Okay. Again, I know I could improve upon that, but the whole point is just to make things a little more clear for you guys without taking up too much screen real estate. Okay. So now we have get bars, which is essentially takes the, that crypto aggregate, for crypto, and brings it all together. Essentially creates almost like a next URL for it, right? Because that's the challenge, is that our aggregates don't help you like with the next page of data. You just get one block of data, and then that's it. You have to handle all the dates. So go ahead and do this. We'll do if not market in markets. Do raise exception. Market must be one of markets. And then if ticker is none, raise exception. Ticker must not be none. Okay, and then we'll do from equals from if we passed it, right? So from if we passed it. Else we'll just make it year 2000. All right. And then 2 will be to today, right? So 2 equal 2 if we passed it. Else it'll be date today. From datetime, import date. Okay, so now we have various markets, right? So we're going to just handle the crypto in this one, but maybe in the GitHub version, I'll handle stocks too. But we'll do if market equals crypto, we'll do response. We've already seen this, right? Self.crypto aggregates, the ticker, multiplier, time span, from, string. We're going to convert it from a string, right? String format time, that month, days, pattern, and do strf. Same thing. %y, %m, day. And then we'll do the limit. Limit equals 50,000, which is the max. And then this will create, that response. And remember, before we ended up creating a data frame out of it. So PD data frame response, then results. Let's set the last minute equal to 0. We're basically just initializing a variable here. So now let's think about what we want to do. We want to loop through all of the results, right? We want to get the last minute or the last date from the result, and then that'll be our next query, right? So let's just say, we'll just say we got a bar for the 23rd. The last date was the 23rd of October. Well, that would be our last minute. We want to get everything from the 23rd on, right? So that's how we're going to identify, what we're going to grab next, and simply the last row or the last timestamp. Okay, this will be more clear as we continue through with the example. We'll do while response results -1, which is again the last row. And then t, remember I converted that to milliseconds before, but that's the time or the timestamp, right? So we'll say last minute in response to make that clear. We'll do last minute equal response results while response results -1 greater than last minute. Sorry. Last minute response results, and that's why you can see 0 will always work, right? Because minute will always be greater than 0. So we go last minute equals response results. We want that last minute dash t, and then we'll do last minute date. Last minute date equals date time from timestamp. We do last minute divided by 1,000. Then we can convert that into string time. That'll be, again, Y, month, day. Now with that data, we can then create a request, right? So response equals self crypto aggregates to ticker, multiplier, time span. Remember the ticker is just whatever ticker is passed in. The multiplier in this case is 1, time span minute. Last minute date is right here, which is essentially the last timestamp, right? But converted to a date of our prior call. Then 2 is simply today. So strf time, year, month, day. And then we'll do that limit equals 5,000 or 50,000, so we can get as many requests as we can. And then we'll call this new bars. So new bars equals PD data frame fonts, which is what we just called right here. And we'll do results. So that'll give us the new data frame, right? Because we've already made a request up here, and assuming, we've already made a request up here. So now we will then keep looping until the last minute match. In a second. But we're going to take new bars, and then we're going to append those bars. But we can't just mush them together, because if you think about it, some of the bars might overlap. We're giving Polygon a start date and end date. We're not giving any minute values. So if our last minute bar was at noon, we're still getting all of those, prior values. So we need to make sure whenever we are merging or appending that we are appending only up until that last minute bar. Okay? Timestamp is greater than our last minute bar. Makes sense? That filters out the earlier bars. Like df date is equal to pd dot do date time dft, which is a timestamp. That is unit millisecond. That simply converts that timestamp into a more human readable date, understanding that the unit is millisecond. Now let's rename our columns. So we'll filter for only the columns that we'll want, and that will be date, open, high, low, close, volume. Now we'll return the data frame, and then if for some reason we did not get data, we'll just return none. We don't necessarily have to do that, but I like to be explicit. Now let's test it. We'll create a new client. We'll do my REST client, pass it the API key. Enter. See that we do have a REST client. Now let's use our new methods. Type client get bars. We'll get all of the crypto bars. The market will be crypto, all of the Bitcoin bars, and the ticker will be Bitcoin. It's actually X:BTC US. What do here? Oh, data. Right, that should be date. We're going to need to add date time also. I'll add that. Now that that's finished running, let's print the data frame to the screen. And perfect. It looks like that's exactly what we want. Congratulations. You now have minute bar data from Polygon IO. And you learned how to also take an existing API and improve upon it. Pretty cool stuff. So now that you have that minute bar data, you can now finally start to test out various strategies. Now, if you need some help with that, hey, that's what I'm here for. So if you click on this playlist here, this will show, again, one of those days. This will show a playlist of a bunch of different ways to backtest various strategies, including stocks, forex, all of that fun stuff. So I hope you liked this video. If you did, please hit the subscribe button, which I think should be around here, and hit the thumbs up, and I hope to see you in the next one. Thanks.